So, before learning about a diode, we should first know what is a semiconductor. A semiconductor is a solid material whose electric resistivity is higher than that of a conductor and lower than that of an insulator. Typical values of resistivity of a semiconductor lies between 10 to the power minus 12 ohms to 1 ohm. At room temperature, the electrical resistivity of a semiconductor decreases with the increase in temperature over a particular temperature range, which is the specific characteristic of a semiconductor. Thus, a semiconductor has a negative temperature coefficient, as this behavior is contrary to that of a metallic conductor, for which resistance increases with the rise of temperature. At ordinary temperature, the pure semiconductor has very small conductivity, and this semiconductor is called intrinsic semiconductor. At 0 degree Kelvin, all the semiconductor in the pure form behaves like an insulator, but the electric conductivity of a semiconductor can be increased by a large value by adding of a small amount of suitable impurity. This process of mixing a suitable impurity in semiconductor is known as doping. Usually, if one atom of an impurity is doped to a pure semiconductor of 10 to the power 6 atoms, its conductivity increases 16 times, and this semiconductor is called impure semiconductor. Some example of semiconductor are silicon, germanium, and tin. Now, when a semiconductor is doped, it creates Now, when a semiconductor is doped, it creates basically two types of semiconductor, a n-type semiconductor or a p-type semiconductor. Now, what is a n-type semiconductor? The term n comes from the negative charge of the electrons. In n-type semiconductors, electrons are the majority carriers and the holes are the minority carriers. N-type semiconductors are created by doping a pure semiconductor with donor impurities. A common, a common dopant for N-type semiconductor is phosphorus or arsenic. In P-type semiconductors, holes are the majority carriers and electrons are the minority carriers. P-type semiconductors are created by doping and pure semiconductor with acceptor impurities. And common P-type dopant for silicon is boron or gallium. Now, what is a diode? A diode is a semiconductor device with two terminals, typically allowing the flow of current in one direction only. It is made of two layers of semiconductor, one n-type doped semiconductor and another p-type doped semiconductor. This combination allows the current to flow from only one direction. Uses of diode. A diode is used to convert alternating current to direct current. Because of its property of allowing the current to flow from only one direction, it can convert the alternating current to direct current. Now we will see a simple experiment with a diode, a LED and a battery. For this experiment, we will need a battery, a breadboard. I have fixed our diode on the breadboard. Here is a LED. I will connect the LED to the diode and one end of the LED to the free pin of the breadboard. Okay, now I will connect a battery to the diode and the cathode of the battery to the cathode of the LED. Now you can see the LED is glowing. This shows that the diode is allowing the current to flow. Now I will remove the LED, and as you can see that the longer end of the LED is always the positive and the shorter is always negative. Now I will connect the LED to other side of the diode and connect the battery. As you can see, the LED does not glow. This shows that the diode does not allow the current to flow from this direction. When the LED is connected directly, it glows, but when the diode is connected to the LED does not glow. The diode restricts the current to flow. So this was the experiment. Thank you.